It's the Friday Cocktail with Anna Glowinski.
Okay, we've just been talking about the universe, and now we're going to the other extreme and looking at microbes. Although the two things are connected, and talking about the past, the history, the journey of microbes on the planet, and actually how our next guest thinks that they can help us tackle climate change, and they have a role to play, which is pretty mind-bending. Peter Forbes, he's written a book called Thinking Small and Large, How Microbes Made and Can Save Our World. Hi, Peter. Thank you for joining me today.
Hello. Thank you very much for having me.
So, you started with a pretty major concept, which is to solve the big problems, you have to think small. And you're talking really, really small. How did you get to this?
Well, you gave a nice lead in when you said that you come from the universe to talking about small things. I realised that, because when you study biology and chemistry, you realise we are medium-sized creatures. The universe is vast, but we discover that the workings of nature are very tiny, but they're vital because that's how nature works. We just look at plants grow. We don't know how they do it, but, they have little nanomachines, proteins in their cells that can tap the sunlight and, create living matter. It's a miracle. But we know how it works now, and we think that there are ways in which we can use what we know about very tiny creatures, microbes, to help us with our big problem with the climate.
And it's just such a huge concept. I don't really know the best angle to take with it, speaking, because you also, how about just explaining to us first and foremost, what are microbes and how have they existed on planet Earth? What's their relationship on our planet been historically?
Well, if you say microbes, to most people, they think germs, they're bugs, they're bacteria. Well, microbes, yes, some of them are. But anyway, bacteria were the first life forms on Earth. Life had to start in a simple way. It's not going to start with creatures like us, great big creatures that can do all sorts of things. So they were very tiny creatures. Microbes had the world all to themselves for over 3 billion years. They created the atmosphere that we have. All of the machinery of life, like photosynthesis, developed in microbes, and they regulated the climate of the Earth. And also they caused huge climate change. For instance, we breathe oxygen. Oxygen is a very reactive element, and before there were living things, oxygen didn't exist in the air. Microbes, by photosynthesizing, created oxygen. And the oxygen we breathe now is only maintained by the action of plants and microbes. So, they built the world we know, and also they created things like, we need metals. The things we need, we need iron ore, we need limestone, and we need coal or gas. All of those were created by microbes in the first place. But you see, when we came along, these things all existed under the earth, and we just mined them without thinking. But that's created this huge problem.
How did the microbes create these other gases and minerals and metals as well? Because you're exactly right. I obviously knew that human life started with something really, really small and evolved and got bigger. But I didn't actually realise that they changed. I thought life adapted to live under the conditions of the planet. I didn't realise we actually formed those conditions. So that, and to anyone listening, I'm really sorry if you already knew this, but to me, that is absolutely mind-blowing. Yeah.
It's a brilliant question. Well, I can tell you how. Think of the White Cliffs of Dover or any chalk cliffs. They are the residue, they're the remains of the shells of microbes millions of years ago, and they fell to the bottom of the ocean and got compressed by other layers. So the limestone that you need to make iron comes from there. In the early Earth, there was no iron ore that we now understand. Iron was dissolved in the oceans. The moment you got microbes producing oxygen, it precipitated all the iron out like rust. And if you look in geological strata, you find bands of iron ore, which we can mine. Coal we know about, that's the remains of plants and also microbes. So all of those ingredients were created by the microbes. So what we think of as the physical environment and the rocks that we can mine things from, a lot of it was actually created by life. In other words, the life changed the world, and then, we end up living it. But we didn't realise that a lot of the things we use actually were created in the first place by microbes.
No, absolutely not. And you mentioned microbes as people see them as germs. And I also remember the Yakult advert from years ago where they talked about the good bacteria inside the yogurts, and they had the little talking bacteria on the advert. So, we've been told you've got these good ones and you've got these bad ones. How necessary is the variety? How many are there, and how necessary is it to have this variety of them?
Well, there are thousands of them, and we've always used microbes. Yogurt is a good example. Brewing uses yeast, which is a microbe. Special cheeses like Stilton, they're blue because of the microbes. If you think about it, if your bread goes mouldy or a cheese, it gets this blue stuff on it. But, when you eat Stilton, it's only a microbe, just the same. You throw the food away because it's mouldy, but if it's a special kind of microbe, it's actually good for us. And also, they now know, of course, that we have lots of microbes in our gut that actually are good for us. And some people, unfortunately, have some bad microbes in them that make them ill. So we're learning more and more all the time that microbes are our helpers. Sometimes we know they're dangerous, so we had to combat them when they are. But think about it. If they were here 3 billion years or more before we came, they couldn't have evolved to attack us. What happens is they're very clever and opportunistic, and we seem a good target for some of them. So, unfortunately, some of them do harm, but mostly, they regulate the Earth's climate now still. You see, you think of nature as a great recycler. If things rot in nature, we know that they get broken down and can be used again by new plants and animals that eat them. But only microbes can break down some things. For instance, all of the nitrogen in the air, and 80% of the air's nitrogen, is produced by breaking down organic matter to release the nitrogen in the air. And then there are some microbes that can turn that nitrogen back into a form that the plants can use. They're the only things that can do that. So we rely on microbes, but it's only fairly recently, really in the last century, that we've discovered how important they are. In 1850-something, Pasteur discovered the dangerous microbes that cause disease. But for a long time after that, people thought that's all they did. But it's not all they do.
And so we're getting now, you've touched on it a little bit already, we're getting now to sort of the crux of your message and how microbes can help tackle climate change. What do you see their role doing?
Well, so we have this big problem that nature is programmed, basically, it's evolved to recycle the carbon dioxide that animals produce. But because we emit so much from our fuel, it's growing all the time. Life can't cope with it. If life could cope with it, we wouldn't have a climate problem. But what we can do is microbes have another way to make some of the things we need. Microbes can be engineered in a quite simple way by breeding them to produce jet fuel. It takes several stages, but basically they start from carbon dioxide. But if you think about it, carbon dioxide is our problem. But so many materials we use are carbon products. All our food is a carbon product. We're carbon products, really. Wood is carbon product, obviously. Plastics are carbon, which make a carbon product. So you can brew up microbes, not to make something like beer. I've been to there's one place in Europe that does this, and they brew up the microbes to produce ethanol, which, if you know, when you go to the petrol station, your fuel now contains 10% of ethanol, besides the rest being ordinary fossil petrol. But you can run cars off 100% ethanol, and you can actually turn that to jet fuel. That's the big thing they're doing now. But you can also make food. I mean, you may know corn is a microbial food that's been on the market for 20 years or more. And now they're trying to make more microbial. And the great thing about that is that food takes up a lot of land, which means that's why we're losing all our forests, which actually store the carbon. If we can make more of our materials, our fuels and food from microbes, it works two ways. It means you don't have to use the fossil stuff. And also, we're going to use carbon dioxide from the atmosphere. At the moment, it's quite hard to get carbon dioxide out of the atmosphere because it's quite a low concentration. So what they're doing is they're taking it out of polluters like ironworks. The one in Belgium, it's a steel works. But they're taking the waste gases, instead of sending them into the air, they're turning them into ethanol. So you get, you're losing the carbon you would have taken from fossil. But eventually, and they're all trying to do this now, but it's not terribly economic at the moment, you'll take the carbon dioxide from the air, you'll turn it into fuel, food, plastics, etc., and you'll leave all the fossil carbon in the ground. So it's a win-win solution, but it should be a big project. Firms are working on this now, and it's actually happening. But, it's like in the war, you had this Manhattan Project, we had to develop an atomic bomb. They put all our resources into that, or the moonshot. To make this really work, you need a big, big project like that.
Well, thank you for that summary. And how optimistic are you? Obviously, you're in touch with all the data and information at the cutting edge, at the forefront of this. But is it big enough yet?
It's not big enough yet, no. But the thing is that it's been proven to work and it's actually out there now. But the thing is, of course, the world is in a very strange state at the moment. And it's true that governments would need to recognise the importance of this. But at the moment, everybody's saying that, climate change, it's all going the wrong way because things like wars increase our use of fuels. Some governments don't believe in climate change. I won't name them. And so it's happening at the worst time. We should recognise that our biggest enemy in the world is climate change. But we've got such a lot of fighting going on in the world, people fighting each other. And that's not a good climate for solving this problem. But to me, the logic of it is so clear. The chemistry of the Earth is well understood and we can see the problem we're creating and we can see the solutions. At the moment, we don't have the will to do it. But, brave people are working there trying to get the message over.
You've got a very logical way of thinking and laying out, everything that you've understood. And that what I'm hearing is that the science is getting there. And obviously farming microbes is going to take up way less space than farming cows. So, there's a lot of logic there.
Absolutely.
But it's about getting political will on board. And what about individuals? Have we got a voice in this? Have we got a role to play?
Well, it's hard. People are taking action. I say that we won't solve our problem by, renewable electricity alone, but obviously that's a big part of it. So people can make the choice of, having solar panels and having electric cars and so on. But you see, what I'm trying to say is the big problem is in nature. It's not only putting carbon dioxide in the atmosphere. We're losing forests, we're losing land. Our agriculture is highly polluting, etc., etc. So it's difficult. The best thing individuals can do to solve the particular problems I'm talking about simply is to recognise the logic and start lobbying politicians, really, because the logic is very clear, but also emotions are involved, and people don't really want to change their lifestyle that much. And governments are afraid that if they don't keep the economy growing in the way that we're used to, they won't be elected next time, etc., etc. It's very hard to get the message over. But when I discovered all this, I thought, well, I had to do this. I've written books about subjects which are, interesting, but not big like this. But when I discovered this idea that over 4 billion years, there's this sort of meeting of the beginning of life and the microbes that, were born then, and the fact that we need them now. This is the first time in the history of the Earth when we've got the problem, we also know the solution as well. So it's such a powerful message. It's such a simple equation, really. But, I think people are a bit wary of science at the moment. Some people are very afraid of it. So I think we have a job to do to get the message over.
I think it's a very, very compelling argument, actually. And you're saying that microbes could provide a solution to so many things. Is climate change causing a decline in microbes? And again, sorry if that's a stupid question, but, I know that animals are going extinct, plant life are going extinct. Are we losing varieties of microbes?
It's a very good question. A lot of people ask that. But in fact, if you think about it, the answer is very much no, because when everything else goes wrong, the microbes do well. So the point is that if we fouled up, the microbes would hardly bat an eyelid. They don't have eyelids, but you know what I mean?
Yeah.
They actually inherit the earth, basically, if we fouled up. They love it because you know that they thrive on things decaying, for one thing. Some of them do. Some of them are created to do that. So, you know, we have this idea that the earth is ours to run. And obviously we have to try to look after ourselves. Every animal tries to live its own life, you know, and sort of propagate itself. And we're just like any other animal. But we now realise that we can't just go through the usual motions. We need to recognise that say microbes actually, having had the earth themselves over 3 billion years, they will inherit it again if we foul up. No, I mean, we may be changing the microbes population. People look at that, but they're so versatile. They evolve so quickly. And they're opportunistic. They take any opportunity going. Yeah. So if we create a horrible mess, they come and clear it up. But it helps them, not us.
Fair enough. And your book, what you mentioned emotions there earlier. What do you hope that readers feel when they've read your book? Is it scaremongering? Is it an alarming book? Is it something to give hope or just intriguing?
I think they should think that it's revelatory about, you know, the history of the earth and our position in it, really, because, you know, we automatically think, you know, life is all about us. And people used to think of nature, you know, I'm looking at my garden now. They think of nature as a lovely thing that gives us food, and we have gardens, and we like David Attenborough's programs. It's a bonus. Not everybody's interested in it. Nature isn't a bonus, it's the whole thing, really, and we're just part of it. And because microbes are small and invisible and sometimes dangerous, we can't believe that they're so powerful. It goes back to what you said at the beginning. Can something so small be so powerful? And it might seem odd to most people, but I can assure you it's true.
Absolutely.
But yeah, I mean, I think the story is thrilling. I think we should be optimistic.
And finally, again, just on your book, what type of a read is it? Is it a chapter book? Is it a scientific peer-reviewed essay? Is it something you can pick up on the toilet and dip into here and there?
Well, it's a popular science book. It's just 7 chapters. It's not a monster book. It's full of stories. It's not a textbook. I found fascinating stories about how we learned all these things. And, you know, it involves all sorts of people. Like there's the Roman poet Lucretius, who was the first person I know of to realise that life worked on a scale that's incredibly small. 2,000 years ago, he actually predicted how atoms would work, and he was right. Then there's Leeuwenhoek in the 17th century, discovered bacteria. Basically, he had the first microscope that allowed us to see them. And then there's a guy called Hiram Weizmann, who in World War I invented this process to make chemicals from microbes, and his process has been developed, and that's what they're actually using now. So the book's full of stories. And it has things like, you know, when I mentioned that chalk is created by microbes, there's a bit of the M25 motorway where it passes through the North Downs, which is made of chalk. And because chalk is a constituent of concrete, on that bit of motorway, they don't use tarmac, which comes from fossil fuels. They use concrete. But it's a very bumpy ride, and motorists hate it. But when I go down there, I curse the bumps, but I always think about the microbes and think, God, isn't it motorist? So it's those little insights. I try to make it a story, not just the facts.
Irrelevant. Well, I think it's absolutely fascinating. You've definitely given me a load of food for thought today. Thank you so much for taking your time and explaining it all to us.
Thank you, Anna. I mean, your questions are great prompts. Really good. Thanks very much.
I'm really glad you enjoyed it. Okay, thank you. Goodbye. That was Peter Forbes, and his book is called Thinking Small and Large, How Microbes Made and Can Save Our World. If you'd like to get your hands on it, you can look it up on Amazon or, of course, the TRE bookshop.